Hello, my name is Philip Black. I'm the Global Emerging Solution Lead for Wood, a worldwide engineering and technology company which operates in energy, infrastructure, mining, and manufacturing. My focus is on helping clients maximize the value they get from all this exciting technology development which is happening around us. My interest extends across IoT, machine learning, AR, VR, blockchain, and I'm interested in how these technologies combine to potentially exponentially increase the value of innovation, which is exactly what a digital twin can provide. Today's discussion is especially important in the rapidly evolving energy transition which we're all a part of. Influential investment groups like BlackRock are increasing pressure on the entire energy industry to increase the direct monitoring of carbon and the transparency of reporting. Individual investors are voting with their dollars as well through specific ESG funds and ETFs. Exxon's facing a very important vote related to this issue of climate change as well as we speak. Energy companies face unique challenges, which makes it challenging to compile information for carbon reporting. I've spent hours looking just for the system which contains the data I need. When there are multiple sources of data, I've spent days trying to resolve the discrepancies and figure out what's the best source for the calculation. Then, after the processing is complete, the report has been generated, everybody breathes a sigh of relief and hopes that next year, maybe the process won't be quite as time-consuming. It's no wonder that today's carbon reports contain only limited detail, are only generated annually with limited auditor assurance. This is going to change. The increased focus from investor means that in the near future, carbon reports once a year with limited details aren't going to be enough. They're going to demand more details and frequent updates. Additionally, with reduction commitments being made publicly and some executive compensation being linked to meeting these reductions, it means there's going to be even more pressure on the groups handling the reporting not to have unexpected surprises. Soon, carbon reporting will have the same level of governance around it as financial reporting. That's why I'm excited about the topic of this panel. Digital twins have the potential to help companies reach their reduction commitments, decrease the amount of time spent doing the reporting, and increase the amount of detail which auditors can use to provide stronger assurances to the market. Companies that can integrate carbon information into their digital twin will be rewarded by the market, investors, and financiers. This isn't easy. There are a lot of potential pitfalls. That's why we have some of today's largest operators, engineering, and technology providers to share how they're preparing for this fundamental shift and the future potential as we continue on the energy transition so you can adapt to this change. Two quick notes before we start. There were some technical difficulties which prevented the measure versus estimate using digital twin to establish your carbon footprint breakout session earlier today. Increasing the amount of measurement and reducing the use of estimates is already becoming more important. This session has been rescheduled for tomorrow at 1 p.m. I encourage you to think about what's discussed today and continue the discussion during the panel tomorrow. Also, there are a lot of places on the platform to ask questions during the discussion. We'll be monitoring the stage chat panel for questions. If you ask somewhere else, we may not see it. So now, let's get to the discussion. We have a great group of people here today, and I'm going to start by having the panelists introduce themselves. Steve, why don't you take it away?
Yeah, fantastic. No, thanks everybody. Good morning, good afternoon, wherever you are in the world. It's fantastic to be here on this panel. As the title goes in through there, Steve Freeman. I'm the head of energy transition for the digital and integration side of Schlumberger. I was previously the head of in AI and innovation, so I'm super passionate about this concepts around how can we build these digital twins, how can we make them relevant to really drive change. You know, in Schlumberger and technology business, we've been looking at digital twins around how do you optimize and plan reservoir performance. The shift now is around how do you do that to be able to plan for future lower emissions, and then how do we take those kind of technologies and how do we apply them in the lower carbon spaces. So how do you apply them in the carbon capture and storage space? How do you apply them in the green and blue hydrogen space, as well as the offshore wind. So, our drive, particularly my drive and what I'm passionate about, is how can we help accelerate the energy transition? So I'm super excited to be here on this panel today. Thanks.
Maan?
Yes, greeting, ladies and gentlemen. Thanks, Phil, for having me. My name is Maan Iskander. I'm managing the Technical Services Department for Aramco Overseas Company, which is the main subsidiary for Aramco in Europe, headquartered in The Hague in the Netherlands. Well, I started my career back 20 years ago with Aramco as a process engineer. I grew up as a process specialist. And then I have been in multiple technical and leadership positions in the company, both in Kingdom and Saudi Arabia and overseas. And basically here we considered ourselves like the engineering arm of Saudi Aramco headquarters in Europe. So we provide all the technology, engineerings, research and developments in the area, of course, when we talk about energy transition and digitalizations, to help our customers in Saudi Aramco with their corporate challenges toward reducing the carbon footprints. And as you know, that we have been engaged as Aramco in the fourth industrial revolutions, IR 4.0, and to support even the company's vision to be the leading world's digitalized energy company with digital twin, of course, technology as one of those core technologies in the Saudi Aramco technology transformation program. So when we look at the definition, which is of a physical representation replicating live assets, it's very essential to understand that when optimizing operations and reducing energy consumptions, I think hence reducing the carbon footprints, this technology can make a big difference in this energy transition. 2 years ago, in Saudi Aramco, we have inaugurated the Saudi Aramco Fourth Industrial Revolution Centers. It's a center located in the headquarters in Dhahran in Saudi Arabia, and it's provide comprehensive insights of digital insight into the health of the key assets in our organizations. It provides live monitoring of flaring, GHG, and energy efficiencies. And connected to more than 3 million data points, we have a crisp real-time analysis of all of our operations, from the wellhead to terminals, covering the entire hydrocarbon chain. So we really believe that technologies like digital twins will play a vital role in reducing the carbon footprints of our facilities, and we are really excited to have this discussion.
Aidan, your thoughts? Introduced.
Hi. Thank you for having me here. So I and my team, we work in Shell Hydrogen, and we manage the IoT platform that is bringing data from our stations and our assets into Shell so that we can analyze this data. I come from a background in tech. I've worked in different data roles, from machine learning to building large data infrastructure and data platforms. And so this role I'm really excited about, combining a passion of mine, which is energy and making sure that we can have a carbon-free future, with my skills in data analytics and data platforms. I believe that this combination is essential for enabling our future, where we can ultimately get to a point where we understand where our energy is coming from and the carbon output, and how we can move forward and optimize the technologies that we use.
Basim?
Yes, good morning, good afternoon, everyone. Basim Khan. So I had the digital and analytics as well as the energy transition work stream in McDermott globally. So most of you will know that McDermott is a energy project delivery company. We design, build, and install projects all over the world. So what is the digital twin, and how does the digital twin fit into carbon abatement issues? So we are an engineering company, so what we see is how do we use technology to select the appropriate process on which to build a facility. So for us, the technology and its digital twin, it's a digital thread, is the means to optioneer a low carbon solution and to optioneer a brownfield low carbon solution on the projects that we deliver. Right now, what do we do when we design a facility? We'll look at the technical features and we look at the cost features of the facility. What we don't do right now, and I think Phil touched on it in his opening remarks, is what is the carbon effect of what we are designing? So for me, and what we're doing in McDermott is building tools that allow you, in parallel to the cost estimation, in parallel to technical decision making, is to bring into the equation a third variable, which is carbon, which is greenhouse gases. We feel that, as Phil said, this is going to be an essential part of project delivery going forward, not only in the energy transition industry, but in the traditional hydrocarbon industry as well. And we'll talk about how a digital twin can help you achieve that. So with that, back to you, Phil.
Thank you. Paul?
Hi, everybody. I'm talking to you from Houston, Texas this morning or this afternoon, and as the case may be. And I feel a little bit like I'm the odd duck in this whole process. I'm the Energy Transition Executive and General Manager for Policy, Funding, and Stakeholder Engagement for Baker Hughes. I don't have a technical background. I tell people all the time I have a bachelor's in history and English, a master's in finance and economics, and 3 years, 9 months, and 28 days in the U.S. Air Force. And all of that qualified me for just about nothing, so I went in the oil and gas business. And that was more than 50 years ago. Most of my career has been in policy work, working with governments, working with regulators to interact with them on regulations and policies that affect our industry. Baker Hughes is about an 18 or $20 billion startup, in that we're about 4 years old now. We grew out of a merger of Baker Hughes, the original company, and GE Oil and Gas. And today we've become an energy technology company providing services and equipment in the core space of oil and gas, but also increasingly in some of the future energy system to include carbon capture, hydrogen, energy storage, maybe geothermal. Our perspective here is mine. I told you about my background because I'm a non-technical person here. But our perspective is that climate change is real. Our industry and our company are part of the problem, but our industry and our company can also be part of the solution. We have got to find ways to reduce the carbon intensity of our products, or our industry will simply not exist in the relatively short-term future. We don't think that's going to happen because we think that technology, and especially things like digital twins, can help us achieve the carbon reductions that are going to be necessary. So I look forward to the conversation, and Phil, back to you.
Thank you. Thor?
Thank you very much, Phil, and glad to be here. My name is Thor Schuler. I'm the innovation lead with Avanade. For those of you who are not familiar with Avanade, Avanade is a joint venture between Microsoft and Accenture. And we've been around for about 20 years doing systems integration, and a lot of our clients are in the oil and gas patch, of course. I'm coming to you today from Houston, and over the last year or so, I've been working with a number of my clients on carbon footprint estimation. And a lot of the people, I think, today in this conference and also on this panel are looking at carbon from an operational perspective, and I think that is good. But the carbon problem is actually much larger than that. And so what we're trying to do, what we're working on, is creating taxonomies and approaches that will help you model your entire value chain with respect to carbon footprint, including both operational and fugitive emission sources and emitters, and working on each emitting type to develop models that help you measure and understand your carbon load across the entire value chain better, because we believe that you cannot control what you can't measure. And right now, our ability to measure is really, really poor along big parts of the value chain.
All right. Well, now everybody has an idea of the background. We've got a wide variety of speakers, experience, and perspectives. So let's get into the questions. Everybody's always asking, how are digital twins impacting you and your company or the company you work with carbon footprint? This is a big, important thing that people are asking. So, Maan, why don't you explain how digital twins are impacting Aramco's and the companies you work with carbon footprint?
Sure, and indeed, this is the core of our discussion today. Basically, Saudi Aramco is involved in many programs, having the goal to reduce the carbon footprints of their facilities. I mean, when we talk about digital twins, we can use digital twin to study the effect and implementations of a technology or a revised processes scheme on the digital twin before the real implementation and the plant commences. And I will list some of the applications that we have used, whether in our upstream or downstream business lines. The first application will be on our Khares oil facilities, which is considered the largest intelligent oil field in the world. It has been even recently recognized by the World Economic Forum as the company's second facilities to be included in the World Economic Forum prestigious Global Lighthouse Network. Those fields, I mean, are equipped with industrial Internet of Things devices and digital twin technology, which enables remote operations using real-time 3D visual reality software to optimize the operations of the field and reduce carbon emissions. This site consists of big data analytics, machine learning, smart sensors, and a remaining useful live forecasting systems, where the digital twin there is used by operations in the control room to keep an eye on end-to-end operations to monitor, predict, diagnose. Even the advanced algorithms can be released to stop, start, or reduce and increase the intelligent field's operations. Those advanced technologies have resulted in the reduction of overall power consumption at Khares by 18%, and reduced the maintenance cost by almost 30%, and cut inspection times by 40%. On the other hand, using machine learning's predictive and prospective analysis, Khares developed its own systems to optimize fuel gas in their boilers. The application contributed to significant annual fuel gas savings and, most importantly, an 8% reduction in CO2 emissions. Now, let me shift you to another aspect where we have iPower, which is a digitalized renewable twins, where in iPower, which is the Saudi Aramco, keeps a close monitoring and diagnostic eyes on its renewable assets from an intelligent monitoring and diagnostic centers at the Dhahran headquarters. Digital twins copies of the renewable systems were created by combining design and historical data. And digital twins of the renewable assets analyze real-time data to predict efficiency and reliability performance using advanced algorithms. Gaps and mitigations actions are identified to provide the optimum operations and maintenance condition to achieve the optimum performance of the renewable assets, especially in the kingdom's harsh climate. Now, another applications are for our North Ghawar oil field, which is the largest onshore oil reservoir, where we have different areas located at different geographical locations in Abqaiq, Indar, and Shadgam, through 15 gas, oil, and separation plants, GASPs, to separate basically crude from water and gas. The production network has been enhanced with several swing and transfer lines to increase operational flexibility among separation plants. And in addition to that, we have introduced a rigorous optimization platform that was developed specifically for North Ghawar by capitalizing on those IR 4.0 technologies like digital twins to optimally distribute the feed to different plants and then different operational scenarios. Of course, the objective here is for that smart solution is to optimize the number of running facilities by shutting down facilities with high energy consumptions based on the set target in that specific month. Of course, that will maximize the assets, utilizations, optimize operational expenditure, and reduce greenhouse gas emissions. The last application that I would like to talk about is in the downstream business. It's all related about the integrated manufacturing operations management, IMOM. basically in our refineries. So IMOMS is designed to enhance operational excellence by providing advanced controls and tools that will help improve profitability, efficiency, reliability, and most importantly, is health, safety, and environment. Those are the 4 pillars for the operational excellence. Those IMOM technologies are also helping to manage the end-to-end operations business in the company for those refineries. And from the order inceptions all the way to planning and scheduling into the time it ships the products from our terminals. And 2 mostly common solutions there in the IMOMs are, for example, the predictive maintenance solution and the GHG solutions, which is by of course, its main existence is to connect all the dots together and help in mitigating those climate issues and reduce the carbon footprints of our facilities. Those are some of the applications that we have identified utilizing digital technology, digital twins in specific, and digital transformations, all tracks in Saudi Aramco. I'll turn it back to you, or maybe to Steve or Paul. I guess Paul.
Yeah, thanks, man. I noted that you mentioned real-time monitoring, and I think maybe that's where I would start my thought process on digital twins. We have 3 real-time monitoring centers based around the world so that we can get 24-hour a day, 7-day coverage of the digital twin technology that we use. And for us, it started out with monitoring the rotating equipment, pumps and compressors and gas turbines to anticipate potential failures, right? To know when maintenance might be required. And that sort of leads me to what I think is really important relative to the use of a digital twin in the future state, in the future system of energy and in this whole low carbon environment. When I think about what our customers are really looking for, they're looking for safety, they're looking for economy, efficiency, and increasingly they're looking for low carbon, right? So, and all of the tools, all of the advantages that digital twins bring to our industry ultimately lead to these kinds of pillars of operation. So if you're safer, if you're more reliable, if you're more efficient, you're going to be less carbon intensive. And so as we think about doing spreading this technology into our industry, I think we need to enhance the real-time data that's available. So talking about additional measurement sensing capability, technology to feed the systems, and then we need to, you mentioned algorithms. We need to be able to actualize the data that we have, right? It's great to have the data. It's great to understand what may result from that data, but eventually you got to do something with it. You got to act on it. And so we, as a company, are thinking more and more about how do we actualize the data that we get? How do we make something real and productive for our customers from that data? So, Aidan, how about you? What do you think?
Yeah, I agree along the same lines. So my team is working on building IoT platform that will help aggregate data from different stations and infrastructure that we own. And this data has actually been, we've actually been able to act on it. I myself personally have made models based on the data, based on real-time and historical data that we have, that enables us to gain further insight that from a first level look at the data, you wouldn't be able to get this insight. So knowing our infrastructure, working with other people in my team that have, specialty in whatever kind of parts or materials that we're using, and then combining that with the data that me and my team have been putting together, we're able to get a greater insight into our infrastructure, and we've been able to make actionable models from this data. And I think that this is the future, as Paul and Maan have described. We need to be able to collect this data in a real-time and historical way so that we can track the efficiency and the operations of our systems through the various stages of the energy platform. So, back to you, Phil.
Fascinating. So it sounds like Aramco's employing digital twins throughout the entire, from the fields to the downstream to the manufacturing through their renewables. That's fascinating to see the integration of all those different systems, because that's been a huge challenge in terms of the monitoring, and Aidan, how the IoT network and taking the action from all the data that the industry has been collecting for years, but has just been sitting or has sat in siloed systems. As well as I like Paul's concept of doing the real-time monitoring globally distributed so that you can ensure the reliability of your assets. So there's a lot of talk and there's a lot of discussion.
Phil, if I may,
Yes.
I just want to follow up, if you don't mind, just one point there.
Sure.
In terms of the real-time monitoring. In our industry, as you think about emissions, you often hear people talk about the concept of the fat tail, right? The big emission that happens periodically, that's the bulk of the problem. And so, we're spending a lot of time talking to government about how do we deal with that so-called fat tail emission, that really big intermittent emission. And the only real solution to that is real-time monitoring, right? Because you never know when it's going to occur. So satellites are terrific. Drones, we got them. We can work with you on them. But the real holy grail here is to find ways to monitor all of the technology deployed on real sites, whether it's upstream, midstream, or downstream, and capture that real-time data. And then you can feed it into the digital twin systems. You can feed it into artificial intelligence systems and actually end up with something that you can deal with. Sorry to interrupt.
Exactly. Oh, that's this is the point is have a conversation. So excellent. We're all talking about the energy transition, all the different alternative sources, hydrogen, carbon capture, renewables. How do digital twins, how can they be applied for developing all these low carbon energy systems that we have to reduce the carbon intensity for the energy we produce? Dor?
Thanks, Philip, and I want to thank Paul for actually setting me up quite nicely here, because I was going to kind of look at this from three different perspectives, right? And so from an operational perspective, I think Paul's absolutely right. You have those fat tail events. They happen when something goes wrong, when something malfunctions, and you have an unplanned equipment shutdown that leads to a release. How do we get a handle on that one? Yeah, real-time monitoring of the telemetry of these events for this is key, so that you can essentially predict when maintenance becomes necessary and can do a controlled shutdown, thereby eliminating or at least significantly reducing some of these fat tails. However, I think that's only part of the equation. If you look from another operational perspective, and I want to use an example here from a midstream thing we've been working on, where let's say you have a pipeline, it carries gas, you have to do maintenance on that pipeline segment, and in order to do the maintenance on that pipeline segment has to be evacuated. So what do? You shut down the pipeline on both sides, and you either have a blowdown or you flare off that gas that is in that section of the pipeline that you have to do maintenance on. And so you can say, well, you know what, there's really not much we can do about it. I mean, the gas is in there, we've got to do something with it, right? And so there are physical technologies that you can bring to bear, most certainly, such as you can bring in a cross-combustion chamber, attach it to that section, burn off that gas in a clean way, and that's fantastic. But we're contending that there's other ways that you can do with digital twins to actually eliminate even having the need to do that cross-combustion in place. If you look at your contracts, for example, your contract schedule, if you look at what gas is scheduled to be transported in your pipeline network, you can simulate and game via a digital twin how you can shut down certain segments of the pipeline, reroute that gas, and find a time and a route where you have the most, the smallest economic impact on that maintenance on the pipe. And so instead of flaring that gas off or venting it, you can essentially reroute it just by having the ability to play out these scenarios using a digital twin of your pipeline system. And we've done that very successfully with some clients. And then the third aspect I would have is, and that's maybe going a little bit counter to what Paul was saying, I do believe that we need to look at some of the smaller emissions, because it's the cumulative total of these small fugitive emissions that make it a big deal. I think the last studies I read were saying that about 25% of the carbon footprint of energy comes out of fugitive emissions. So it is a fairly large part. Is it the low-hanging fruit? No, it's not. It is actually really, really hard to do, but we got to get a handle on how we look at identifying and measuring fugitive emissions across the value chain. And I think digital twin can be a tremendous capability here, because again, you can model this in the lab and you can scale it out with a twin across your entire ecosystem, your entire value chain.
Steve, what about Schlumberger? What you personally, what do you see the application of digital twins for low carbon?
Yeah, no, thanks. I agree with many of the things that the rest of the panel have said here. I think for the oil and gas operations, then there's clearly kind of real-time monitoring. I think potentially more important for a lot of us will be how we model those into the future. How do we make insightful changes for reducing emissions long term? But that's oil and gas. Here there's a big focus on kind of how do we deal with low carbon energy systems, hydrogen systems, carbon capture and storage systems. The interesting challenge in this space is that these are going to be a cost marginal business. The world needs us to be able to do this faster and more effectively. And so that means that what we need to be able to do is to be able to plan these things more rigorously and more quickly. And that talks very much to digital twins. So it's taking the technologies that we've learned to do these big infrastructure projects in things like oil and gas, but then pivoting them to apply them to carbon capture and storage systems, to green and blue hydrogen systems, and also to offshore wind systems. There's a key piece here which is around, digital systems are both for the planning stage and then the operating stage. In the hydrocarbon space, we're clearly more in the operating phase. In the low carbon space, we're very much more in the planning phase of these systems. So when we do this planning, we want to look at this planning at multiple different scales. We need to plan across the entire infrastructure system, and we also need to plan at the small scale. So, for instance, on a carbon capture and storage system, we need to be able to plan capture and compression, transportation, site evaluation, and injection, all the way down to what will happen to that CO2 when it starts to leave the wellbore and go into the reservoir. And on the green hydrogen system, for instance, we need to be able to plan across where's the renewable systems, how does it interact with the grid, how does it interact with the electrolyzers, the ammonia plants, and the shipping systems, to be able to optimize that end-to-end system, but then bring it all the way down to what happens inside the electrolyzer at a molecular level. And if we can do that, we can drive out cost, we can deliver these things faster and more effectively, and we can accelerate the energy transition. And that's absolutely where we're heading towards, and we're working with partners. So again, super excited to see how we can apply this and really make a difference on a global scale. So with that, I'll pass across to Maan.
Thank you, Steve. Let's always remember that when we speak about digital twins, it's adding a new dimension for simulating, for monitoring, and for control and data analytics. And I consider it like a digital revolution of how we used to do our business in terms of simulations and monitoring of our data points. Now, when we speak about reducing the carbon footprints and the energy transitions, let's say that we are also having almost among the least carbon intensity compared to our peers in the industry. But yet the journey that does not stop here. We believe that hydrogen is emerging as a low carbon fuel of the future for the energy transition. However, currently the vast majority of hydrogen consumptions occur at the point of its production, where it's mainly used as a chemical feedstock. So I will say that, therefore, one of the key challenges for the hydrogen economy is understanding how hydrogen, and could be also ammonia, can be integrated into the existing energy infrastructure. Another related challenges to this topic will be the need to build new infrastructures such as the large-scale production plants of blue and green hydrogen, which will need to be integrated again into the existing energy infrastructures. So when we speak about digital twins, we'll have a key role to play in the development of the hydrogen economy, starting with how to operate those new production plants, especially green hydrogens, where there is a limitations when we speak to the scale requirements. And for the case of the blue hydrogen technology, such challenges will be more focused on the CO2 capturing and storage. So digital twins can help with the control and operational strategies of those plants, such as establishing an optimal operating set points and integration with the balance of plant components, as well as various subsystems that need to be developed, integrated, and optimized. Now, many large-scale hydrogen plants will be built, with a close proximity to existing industrial clusters, such as refineries, ammonia plants, harbors, ports. And digital twin can be used to study how best to safely integrate those new infrastructure with the existing infrastructures. I would like also to jump to another very important role for the digital twin, which is on the training aspects. It will be to provide like a platform to enable fast operator training and competency assessment. The digital twin will provide a solutions and a means of training control room operators, technicians, even engineers, familiarizing them with the new process scheme, with the processes before the startup of those new facilities. Digital twin can provide a safe virtual environment where process control and operational solutions are designed and tested before being applied to the live plant. And thereby we can reduce the risk associated with upscaling plant designs. So we really do believe that, having a digital twin applications embedded and having the right integrations between the existing energy infrastructures and the new hydrogen and ammonia infrastructure that need to be built adjacent to those facilities is extremely important to predict some of those anticipated changes and behaviors of those operations, and to co-op our operators and technicians and engineers with the right knowledge and experience to handle such operations in the future. And by this, I hand it back to Wasim. Tell us about your thoughts.
Okay, thank you very much, Maan. So let me just start with a word of caution. So we're all technologists here. I'll put you, Paul, in the same category as well, because you've been working in technology for so long. We'll call you an honorary engineer. So we're all technologists here. So we have this great habit of believing that technology will solve all of our problems. So the word of caution is, as we move to these new energies, these alternate energies, hydrogen, carbon capture, geothermal energy, technology, to use a mathematical term, is a necessary but not a sufficient condition to achieve success in the new energies. We need to be cautious that our work processes are built for a different era and they're built for a different industry. So to really succeed in the new industries and the new energies, we've got to take a very hard look at our work processes and ensure that they are fit for purpose. We've also got to have a workforce trained for the new energies. So again, word of caution, technology is just one pillar of success, and it's not necessarily the most important pillar. Moving on, let's start with the end in mind. What are we trying to do in hydrogen, carbon capture, all of the new energies? We're trying to deliver a robust solution which is cost effective. Because, these energies at the end of the day have to compete with traditional energies. Government subsidies will not last forever. So what is the role of a digital twin? As we see it in McDermott, as I see it, is that we need to introduce into our design and build process a third variable. Technical reliability is one, cost is the other, and the third variable is scope 1, scope 2, and scope 3 carbons. Using the typical definition. So as we design a facility, the digital twin and digital tools will help us make choices which are not only technically sound and cost effective, but are also low carbon solutions. So quite often what we will do is we will engineer, and then we will calculate the carbon, either scope 1, scope 2, or scope 3 carbon into the system. What we are saying is, how do we do it as a parallel exercise? And that's where digital twin comes, or digital technologies come into their own, because we have the ability of running multiple, think of it as multiple simultaneous equations. My apologies for Paul getting really technical, but as technology allows us to run this multiple simultaneous equations, come up with iterative solutions which are low cost, low carbon emission, and reliable. So to me, that is where technology will come onto its own. Now, that's during the design phase. In the operations phase, we have an operating digital twin, which will allow us to find the optimal operating point, not only in terms of energy efficiency, which is directly correlatable to carbon emissions, but also in terms of carbon emissions. So how do I tweak my hydrogen plant, my electrolyzer, my green hydrogen plant? And as you know, in Saudi Arabia, the NEOM project is going to be one of the largest producers of green hydrogen. So how do we tweak our facilities in real time, using real-time data that many of us have talked about, that Thor is talking about as well? How do we tweak that to ensure that at any given time, I'm at my optimal carbon or greenhouse gas emission point? So to me, the digital twin, where does it play a role? In design and build, it plays a role in optimizing my design and my build to have the lowest carbon, scope 1, scope 2, scope 3 carbon. And in operations, same. How do I tweak my operations in real time so I can minimize my scope 1 and scope 2 carbon emissions? So back to you, Phil.
Excellent. I agree. Scope 1 and sometimes, scope 2 can be managed within individual digital twins and monitored. The challenge, I think, is fascinating in that to do the scope 3 across the entire supply chain means that information will have to be somehow shared across companies. There has to be a way to be able to calculate your portion of the scope 3 emissions. And that's something that's proving to be a challenge, not just for energy, but for the entire world. So that supply chain of emissions and the allowing, because I believe at the end of the day, everybody's going to want a carbon price tag. They're going to go not only the cost of the item, but they're going to want to know what's the carbon cost of the item. And that's going to shift consumer preferences. So companies that can deliver accurate, instant data, detailed to the level that they know how much of this product was used in the manufacture of another, your device or your clothes or anything, can be a changer in terms of value that customers and consumers will pay for that product. And with the energy industry being kind of at the starting point of the supply chain, it's crucial that we start being able to provide that information to everyone else as it goes through the chain. So excellent points, Vaseem. I really like that. And Maan as well, the integration necessary so that it's not just one digital twin for operations, but then how do you get the information from the design phase digital twin to the operation? So how do you ensure that transition takes place successfully for your thing? That brings me to the next question, which is, we talked about what tools we're using. We talked about how these tools can be integrated, but what other digital tools need to be developed that can help reduce carbon emissions? What aspects are being ignored that people aren't talking about that really should be considered and are considered essential to your companies? Paul, we'll start with you.
Thank you, Phil. Since Vaseem awarded me an honorary engineering degree, I think perhaps I'm going to use my time to give you an example. So Baker Hughes, as many of you will know, sells or rents pipeline pigs to inspect the internal surfaces of an oil or gas pipeline. And these things are heavily digitalized or heavily instrumented, and they flow through the pipelines. They take 1 million measurements a second. And so if you think about a 30-mile length of pipe, there's an enormous collection of data. Pigs that do this kind of work are really, really good at seeing what they have seen before. But they're terrible at identifying something they've never seen before. So the more data and the more data verification that a pigging company can have, the more accurate their prediction is going to be about the nature of the corrosion or the crack or the dent or the potential weld failure or the diminishment of the wall thickness and all these sorts of things. So a company like ours, we try to get as much of that actual, they call it dig verification, from our customers so that we can validate what the pig saw as it travels through the pipeline. But if you think about digital twins and artificial intelligence and potentially the opportunity for a variety of suppliers in this space to sort of share data about the characteristics that these pieces of equipment find, we expand the knowledge of the entire pig fleet, if you'll permit that, and move from a situation where the pig travels through the pipeline, the pigging operator gets a report, he goes through the report manually and identifies certain features, and then they send the features report to the client perhaps 6 months later, and then the client develops a 5-year plan to address what they believe to be the most impactful features in that pipeline. And the point of all of this is that if we could do that more efficiently by integrating the data, integrating the system knowledge, using digital twins, we would avoid what Thor talked about earlier, and that is that we wouldn't necessarily have to stop a pipeline's operation for maintenance and then perhaps have to deal with the blowdown problem. We might avoid catastrophic failures in the system, such as maybe occurred years ago in near San Francisco. And ultimately, we become safer, we become more efficient, and we become more reliable, which is what the system really needs and leads to the kind of low carbon systems I think of the future. So a pipeline example, but perhaps a thought about how we might deploy digital twins and artificial intelligence across a broader spectrum of our industry.
Fascinating. I'm interested. Aidan, in you're working with IoT and data. What tools do you wish you had right now that would make your life easier?
Yeah, so on my team, I'd say the biggest problem we have is around communication about the data. So we collect a lot of data, like Paul mentioned. For his product, we collect a lot of data ourselves too, and the problem is what do you do once you have that data? And that becomes an issue of communication, because you can collect different sensor data, different reports, and put all these things together. But if there's some kind of miscommunication, maybe somebody uses a different set of units, or they have a time zone difference or something like that. So very simple mistakes, or not even mistakes, but just miscommunications, can lead to a lot of work to fix these and make corrections. And so I think that moving forward, as we collect more and more data, which is just happening in the world in general, is making sure that everyone is able to understand what this data means, and so that we're all speaking the same language and we can all communicate transparently. Because as we bring more and more data together, that brings a lot of power to the table, but also brings a lot of work in making sure that we're understanding what we're seeing, and that we're not misinterpreting the data, and we're making sure that everything is done very accurately and safely. And I'm not certain of what kind of tool would enable that best, but I think perhaps this is what Wasim was mentioning, that not everything is about technology, but there's also, you need to bring people together. and have people work together and communicate. And once as we develop and roll this out, I think that will be one of the most powerful aspects to our data future.
If I can, Phil, if I can just add to that, and Steve will actually understand this point, is one of the challenges in our industry is that we don't have a data standard for the, unlike the subsurface where the Open Data Initiative, which Schlumberger, what, Steve, it must be 30 years ago now, right? Initiated, we don't have a common data standard for the industry. Now, as we move to energy transition, it becomes even more important that data can talk to each other. Because remember, what we transfer is actually not data. We transfer information. So when we strip the context out of the information, it becomes very hard to use. To use. And a simple example: if Baker Hughes delivers us a compressor and we ask for a 3D model of the compressor, they will deliver the 3D model of the compressor, but it's not compatible with the 3D model of the rest of the facility we've built. So basically, it becomes a geometric model. And what we end up doing, if the client is sophisticated and they say, no, I want the same underlying standards, we have to remodel it. Why? Because we use Aviva, we use Hexagon, we use Bentley, but the way we use it is different for everybody. Even within a company, we use it differently. So, Aidan, to answer your question, I think one of the key for the energy transition industry is an agreement on data standards.
And it's interesting to see there are a couple of initiatives underway. There is an organization called PIDEX. I don't know whether you're familiar with them, but they are working.
PIDEX, Mimosa, CII. IOGP has, the JIP or the old CFOS JIP 33 or the 36 running. There are a number of initiatives. I agree, Paul, but we're not there yet.
Right. Absolutely.
Or what digital tools are in the works? What can we look forward to help solve these problems? I find the concept of units of measurements, time zones, timestamps being a real challenge. How can the tools that are coming to market help us address that?
Yeah, before I answer that, I want to touch on one thing that you said, Philip, that I think is really, really important, that I think we need to start coming together at. Oil and gas is a very, very collaborative industry. If you think about what it takes to put into production a site, it takes many, many different parties to work together. They are on site during various times, each of them producing a certain carbon load onto the system, and trying to figure out a portion, so to speak, that carbon load and sharing that, and figuring out ways that we can understand, if I'm Schlumberger, I'm on a site and I do a certain piece of work, that I'm interested in understanding what my carbon contribution is, but I don't want to necessarily be dinged for the carbon contribution from the other guy that's sitting like 30 foot of me, right? So how do we deal with that? That's a very, very tricky problem. I think we need to start thinking about multi-party systems to collate the different carbon measurements that we have, or the carbon models that we have for individual contributors on a site, to bring those together. And I'm not sure that there's any work done right now in that area. I think we need to start that. The other thing is, I think I would expect manufacturers of equipment to become a bit more proactive in terms of providing to us models that help us understand how the carbon footprint on a particular piece of equipment is affected by certain set points, so that we then can plug those things into our digital twins as we build these sites, as we engineer these facilities, so that we can have that ability to set optimal set points that minimize carbon emissions. Now, on the data normalization, data ingestion thing, I don't know who said it. I think it was Wasim. I could be wrong, but yeah, let's come together as an industry and let's agree on a taxonomy, on a standard, on a data model that specifies the measurement, the units of measurements and things like that. Because then we can build transformation, our individual companies to comply with those models. Even if they don't want to adopt them internally, at least there's an interface that we can work against. Start. I would say, and I think it was Wasim too who said that. We strip context out of the data that we're getting. Why do we do this? let's stop stripping the context out. Let's leave the context in, because that'll help with things like date-time conversions and things like that.
I'm glad PyDex was mentioned, because that's a very interesting initiative, in terms of just trying to address the larger data interoperability issue. And I've talked with them a little bit and been on some seminars that they're working towards that ability to provide that carbon. Now, it's static information, just to allow a placeholder for that data. But I find it fascinating to think about, you're right, the equipment models themselves need to be enhanced to provide that carbon information, so that, you're right, we can make better decisions. It's about integrating. It's not about just, this is the carbon. It's about just including that in the many aspects of the decisions we make and when we have to make, and including information and in optimization, limits that we've never before considered.
Phil, I want to pull on that thread. I'd like to pull on that thread just a little bit. Across our industry, we've become very, very collaborative in the space in safety, right? We don't, as a series of companies, we don't generally think of safety as a proprietary space. If somebody comes up with a really good idea, it's all about trying to keep the industry and the people safe. And I want to suggest to the group, and maybe following up on really what Asim said about our operating principles and our operating practices, I think we're needing to move towards a situation where sustainability is no longer considered proprietary. That's a place where we're going to have to learn to share and work together to solve this problem. It's a huge problem. It affects all of us. So I think it is a mentality that we're going to have to begin to accommodate as best we're able in a very competitive world.
Yeah, if I could just kind of make a comment on that, I think kind of what we're seeing is that there is a need for transparency and openness, which is far beyond what we've done before. And it's very much related to the data and how we're using the data and how we're going to optimize these systems. The other piece is that we're talking about integrating across many different types of systems, and this is a level of integration that we need to optimize for that, again, we've never really done. So I think it's digital twin is at the heart of this solution, but unless we crack the data problem, then we really won't have solved the bigger challenge. Yeah. So I think there's a lot of consensus in the group here that there's a couple of three really big things. If we can crack those, then we can make a substantial difference.
Phil, if you don't mind, just if I want to give a quick summary of the recent discussion that we had just now. The key word will be collaboration. We cannot work in silos anymore to address those climate changes issues and to address those decarbonizing our facilities and looking forward for the energy transitions. We have to work in partnership. Vertically, horizontally, with all the suppliers, with the vendors, with the government entities, with academia. We have all to work together. We have a common objective that we need to be accomplished, and we have to rely on the experience of each other. So I like the idea and the comment of being transparent and to have the sense of openness when we have those discussions going forward, and trying to address those challenging situations.
I think there was someone else who's going to speak real quickly before as we finish up.
Yeah, one thing I wanted to kind of also maybe leave the audience with to think about is we've talked a lot today about reducing or eliminating emissions, but you can only go so far with that in the industry that we're in, right? If your company wants to get to net zero, you also have to think about the other side of the equation. What can you do to take carbon out of the system using reforestation, using those type of approaches to get credits to offset the emissions that you cannot eliminate effectively and easily.
Excellent. Well, I've enjoyed this discussion with everyone today. We've had a lively. There's lots of opinions, and we have the common theme that data has to be standardized. And I know everybody talks about data, but the ability to integrate the different kinds of data, the time series data, the design data, all those parts of the data have to be considered and integrated as part of the solution. So I'd like to thank all the panelists today for your time, for being here on this panel, and look forward to talking more in the measure versus monitor discussion tomorrow at 1 p.m. Thanks a lot.